What if we use the trival zeros in Reimann zeta function for defining zeros in digital computation? Imagine that we have zeros in digital computation that numbered from 1 to 11. These are the digitation from 1 to 11. And these zeros are numbered 1, 2, 3, 4 sequentially, each one following the other. Imagine that the first zero will be the first zero in trival zeros of zeta function in Reimann zeta function. To doing that, we have to change the minus to I2, because we know that I2 is equal to in this way. I2 is in this way is equal to minus 1 root up to 2. So for that purpose, we change, for example, minus 2. We know that every even number is a trival zero. So minus 2 will be 2i2. Minus 4 will be 4i2. Minus 6 will be 6i2. In this way, we will name every zero starting from the 2i2 till the last one. And we know that the trival zeros are every even number. Negative even number is a trival zero. By this way, we can make it easy for computation to recognize it is zeros. So the zeros will have names. The zeros will have names. So when we want to deal with any zero, we can have its equation completely, and we can plot them on graphs. These values in quantum computing will be very important, because we know that zeros are not ordinary zeros in quantum computing. As we add definitions to the zeros in quantum computing, it will be easier to deal with that zeros. So the equation will be like that. For example, if we have a zero in position number 1, it will be 2i2. In position number 2, it will be 4i2. In position number 3, it will be 6i2. And it is recognition is very easy. Just divide it by 2 and it will give you the position. For example, 6i2 divided by 2, it gave you 3. The location is 3. If you have 16i2 divided by 2, it will be 8. So it will be the zero number 8. By this way, each zero in the digital computation for quantum computing will have its special trival zero values, and it will have all the definitions that will be allowed for that trival zeros, from regarding equations, for mathematical solutions, manipulations, and it will be easy for making graphs by them, plotting them on graphs, and even for saving memory. You will just have a plot, and you can then download that into any it will reduce the space for saving zeros by magnificent amount. As we know that quantum computing, it will contain too much information analysis, and by this way, if we have names for each zero, it will be easier, and it's the only way that we should not regard them as a zeros, just like in ordinary computation that we do, that ordinary zeros have no any value more than 0. No. For example, 6i2, it will be a 0 in position of number 3, and this 0 we can manipulate it, plot it, graph it, and everything that we want to it. So use of trival zeros in Reimann hypothesis for solving zeros in digital computing, for quantum computing, is very, very essential, and it is very easy.